Hey everyone, welcome to my channel, and today you're watching Git full course part 1. In this session, we'll go through what exactly is version control, why we will be using version control, what is Git, a bit of history of this version control and Git. Then we'll learn about the key concept of Git. Okay, I can't wait to explain all this to you and teach you how Git works. Okay, and then in few days we'll have the part 2 as well. So let's continue the part 1. What exactly is a version control? Now, version control, also known as source control, is a system that help you manage the changes to a file or a set of files over a time. So you might be making changes in a file over some time. Say today you make changes, tomorrow you make another changes, and keep making changes, right? So any point in time, who made the changes, when made the changes, and maybe what is the reason? You can understand all that with the help of such version control software. Version control commonly used in software development, but it can also be used in other types of files such as documents, spreadsheets, images. Now, it's up to your imagination and use case. Where do you want to handle this version control, or for which file you want to do version control? But for any kind of file, you can do version controlling, right? Now that we understand what exactly is a version control, let's do a bit more deep dive into exactly what are the reasons we should be using version control. Now let's learn about that. So first reason, keep track of the changes. So version control allows you to keep track of the changes that you made to a file or maybe set of files over time, and you can see who made the changes, exactly what changes were made and why the changes were made. So you can track all that. This can be particularly helpful when you're trying to troubleshoot or debug any issue. Now, the second point, collaboration. So, version control enables multiple people to work on the same file at the same time without overriding each other changes. And this can be particularly helpful when working on a project with a team of many people. Third point, versioning. So with version control, every changes is saved so that you can go back to previous version of changes if it's needed. And this can be particularly helpful when you need to revert back to earlier version of a file, or you need to see how a file changed over time, like reviewing the changes, right? For that also, versioning is useful. Now, next point is branching and merging. So version control allow you to work on multiple version of file simultaneously and merge changes together. And this can be particularly helpful when you want to experiment with a new feature, or maybe fix a bug without affecting the main code base. This is a very important point. Now the final point, backup. Now it's final point I'm saying here. There are multiple reasons, but these are the top reasons. So backup. Version control allow you to provide a form of backup of your files. So as they store in a central repository. This can be particularly helpful in case of hardware failure or other catastrophic events. So maybe your computer, you have the code, right? And for some reason your machine gone bad. Could be any reason, or maybe your hard drive got corrupted, or a machine something is corrupted, virus affected, any number of reasons. Since your code is actually stored in a remote repository or a remote place, okay, you can again set up a new machine and you can pull, or you can get all the changes in your machine back, and you can again make the changes, and you will push your changes again back to the remote storage. So you can do all the stuff. Now overall, version control is an essential tool for anyone who need to manage changes to a file or a set of files over time, particularly in the software development where collaboration and versioning are super critical, super important, right? Version control. Now let's understand the next point. Now let's learn about the types of version control systems. So there are two main types of version control system: centralized version control system, in short we call it CVCS, and distributed version control system, in short we call DVCS. Now what is centralized version control system, or CVCS? Now in a CVCS, all files and their respective version are stored on a central server. Developer check out the files from the server to work on them, and then check back them in when they're done. Okay, just simply pushing back to the server, they pull the changes. An example of this CVCs are include SVN, the subversion, and CVS, which in a full form, concurrent version systems. So this is like CVCS. Now what exactly is a distributed version control system? And this one is actually getting used everywhere. Okay, so listen very carefully. In a DVCS or distributed version control system, each developer has its own copy of the repository, and they can work independently and simultaneously, and changes are synchronized between copies of the repository when a developer push their changes to a central server. Example of this DVCS include Git, Mercurial, and Buzzer. Okay, and the difference between the CVCS and DVCS is that in CVCS, all the developers work on a single copy of the code base, while in DVCS or distributed version control system, each developer has his own copy of. This makes DVCS more flexible and better suited to distributed teams. While CVS can be more suitable for centralized team, additionally, DVCS or distributed version control system are more advanced and branching capabilities than CVCS. So you might want to, of course, use this DVCS or distributed version control system. And of course, we are going to learn Git, which is a DVCS, by the way, right? Now, let's learn a bit about the history of this version control, and this is very interesting. Now, of course, it took a long to come this up to this version control system. Of course, version control systems are complicated now these days, but at the beginning, how they handle. Let's learn about that. So the history of version control management can be tracked back to early days of computing when developers were working on large software projects with multiple contributors. In early days, developer would often make changes to a code base and save multiple copies of file with the different names such as program v1, program v2, and so on. This is so awkward, right? If you think about current days, how we are handling code, but and that time that is the only way. Now, this approach was, of course, error prone, difficult to manage, super difficult to manage, particularly as the number of contributors and size of the code base grew exponentially. And just as necessary is the mother of invention, so the version control management system came into place. Now, how it started? I mean, what was the year it started? So, in 1972, SSCS or Source Code Control System by Mark Rockwell is actually released. Then on 1986, CVS or Concurrent Version System release. In 2000, Subversion released, and on 2005, we have Git, our beloved Git, right? So that is a bit history about the version control journey. So I hope you understand the bit of history here. Okay. Now let's have the entry of Git. So welcome Git, but wait, who are you? So Git is a distributed version control system used for tracking changes in source code during software development. So it was created by Linus Torvalds in 2005. So yes, Linus Torvalds, the creator of Linux, created this Git as well. So while he was working on developing Linux kernel, he created this one. Now, Torvald created Git to address the shortcoming of existing version control system at that time, and such as their slow performance with large code bases and the lack of good branching and merging capabilities. So he was kind of frustrated with the current version control system. So that's why he created his own. Now, he wanted a version control system that could be fast, could be scalable, and able to handle distributed development workflows. Okay, so again here necessity is the mother of inventions. The name Git actually a British slang term meaning a foolish or unpleasant person. Okay, now Torvald chose the name because he would actually supposed to have another name, but another name was trademarked, so that's why he chose this name, and that's how we have this Git. Okay, now Git quickly gained the opportunity among developers and development teams, and that's why since then Git becomes one of the most used tool for source control or version control management. Okay, now it is known for its speed, flexibility, and powerful branching and merging capabilities. And it's used by companies and organizations of all kinds, like small, big, medium. Every single company is using Git only for their source code management or version control management, right? And of course, all the open source projects also heavily using Git only for their version controlling requirements. Okay, I now hope you understand what exactly is a Git, right? Now let's learn about the cloud-based solutions, which is GitHub, Bitbucket, and GitLab. Now, cloud-based solutions such as GitHub, GitLab, and Bitbucket provide a user with a platform for his version control and collaboration on software development projects. And this platform offers several advantages over traditional local versioning system, such as easier collaboration and accessibility and improved security and scalability. Now, let's go with like each one's a bit overview description. So GitHub. Now GitHub is one of the most popular cloud-based solution for version control, particularly for open source software development projects. And it offers features such as issue tracking, pull requests, code reviews, making it easy for teams to collaborate and contribute to the code bases. Now, GitHub also integrate with wide range of third-party tools and services such as Jenkins, Travis CI, and Heroku, and it also provides built-in CI/CD capabilities using a service called GitHub Actions. Okay, now let's learn about the GitLab. Now, GitLab is another provider for cloud-based solution for version control and offers similar features just like GitHub. However, GitLab also includes a built-in continuous integration and continuous deployment CI/CD capabilities, allowing developers to automate the testing, building, and development of their code. And GitLab also offers built-in project management tool and support for Kubernetes, making it a very popular choice for DevOps teams. Okay. Now the third option is the Bitbucket. Now Bitbucket is, on the other hand, is more focused on private repositories and secure collaboration for teams. It is particularly popular among small and medium-sized businesses that need to protect their source code, work on confidential projects, and Bit also offer built-in CI/CD capabilities, although it's not expensive such as for GitHubs, okay, or GitLab in general. Okay, now these three are kind of a very popular option. There are of course many other options available. For example, AWS have its Git Commit, Azure have its repositories, and all other cloud service providers have their own solution. But these three are particularly super popular. Okay, now overall cloud service provider like GitHub, GitLab, Bitbucket offer a range of features and benefit that makes them ideal for modern software development projects, and they enable teams to work collaboratively and efficiently while providing essential version control and project management capabilities. Now that you've learned about this cloud-based solution, it's time to get our hands dirty with Git. So first step first, we should install the Git, right? So how you can install the Git? You see the link, this one. You will of course find the link in the comment section or in the description, or you can simply go to the gitscm.com, and from there you can just install Git based on your own operating system. Now it could be Windows, it could be Linux, or it could be Mac. You just select what is the operating system you have, and based on that you do the installation. So I've came to this Git SCM site, and if you come here, you'll see the all instruction related to installing Git in your system. Now, if it's a Linux, you see the option sudo. I mean, if it's suppose RUHL or CentOS, this kind of system, you install sudo dnf install git all. If it's a Debian or say such as Ubuntu, you would have run this command sudo apt install git all. Suppose it's for Mac, then you see this option gitscm.com download Mac, and see they're asking to run this preview install Git. So let's run this command and see it install the Git or not. For me it's already installed, but just let me show and run the command. So let me run now, and it will of course show that it's installing, and because I already have Git installed in my system, so it will maybe update it probably. Okay, let's see. Now, normal cases in MacBook, if you have Xcode, it involves Git. So by default, you already have it. Okay. If not, this will definitely install Git in your system. Now, to see that Git is installed, you can run this command Git, and okay, you have the Git command is working, right? You have your all the commands and everything in place. So Git's working now. See, if you have Windows, then you can of course go to this one Windows, and you have the option to download for Windows setup, even it's 32-bit or 64-bit, or if you want a portable version, you can install the portable version. So you have all these options. Even you can use Chocolatey, that is package manager for Windows. That also you can utilize this one. Okay, so you have, if you're a Windows user, you also have multiple options. You can use any of it. Okay, so this is how you come to this page and install Git as per your OS. Okay, now that you have installed Git, the first step you should do is actually configure your global username and global email. This is very, very important. Okay, now let's run the command. So let's go. You simply have to run, let's clear this and have git config. So git config, then dash dash global, then user dot name. It should be your name. Say my name is Sandeep Das. Sandeep Das. First run it. Okay, so it will configure the global username. Then we will update our, or we will add our global email. Okay, same command. So git, similar command, git config, then dash dash global, then user dot email space, then your official email. So for me, for example, Sandeep dot das 5 at the rate of gmail.com. Okay, if I do enter, that's it. So I have configured my name and email just like this. Okay, and this is a very important step, so you should follow that. Okay, now let's come to the slide. Now we actually covered or configured the basics Git in our local system. Now let's understand the key concept for Git, and as we progress through more of this key concept, we will also do hands-on. So keep your system ready. Okay. So first thing we should be learning about is init or Git init. Okay. So what is Git init? So Git init is a command that in the Git version control system that is used to create a new Git repository. Now, if you want to create a Git repository in your local system, you have to run Git init. Okay, and when you run this Git init in a directory, it create a new Git repository in the directory, and it also create a .git folder also that I will show you shortly, which enables the version control for your files for that particular directory. Okay, and how you use the Git init? Open the terminal and command prompt, then go to the directory that you want to create that as a repository, then run the command git init, and it will create a directory called .git in your current directory, and this directory will have all the files and folders needed to manage your repository. And now you can start adding file to your repository and use git command to maintain them. Okay, now let me show you how they get done. Okay, so we already have configured the global username and password, the email. Now clear the screen and let's make a directory. We'll call it we'll call it new repo. Okay, or you can call it a demo repo. I think that's more suitable, right? We're demoing stuff, right? So demo repo. Now let's go inside this demo repo. So demo underscore repo. See, now right now if you do run git if you want to see the status of your git repo, you can run git status. If you run this status, not a git repository, which means that you don't have this .git folder. So let's run the git init. Git init. The moment you run git init, it will become a git repository. It will create a folder. So if you do ls la and see there is the dot or hidden folder .git. Let's go inside this git folder. So .git. You see right now, like whatever is required, the file system required in order to for this directory to become a repository, it's already there. It have head, description, info, refs, config, hooks, objects, and we'll come to all that. What this means, we'll come to that as we progress through different slides or different concepts. Okay, so now you understand we have created a git repository. Now if you do git status, okay, it will show on the main branch because the default branch is now the main branch, and no commit says nothing to commit. We didn't add any file or anything. Suppose we add a file, okay, touch, for example, we are creating a blank file, touch sample.txt. Okay, now clear the screen, for example, and run say git status. Okay, if you run it, sorry, git status, see it's saying one untracked file. So now this repository is enabled and we have the git working fine, right? Now let's learn about the next concept or next key concept in git, which is the uh, Git repository structure. Okay, now in Git repository structure, you will see I just show you the file system, right? So there you see some directories and all. So let's learn a bit of this, what it is and all that. So in Git repository is a version control system that store all the files and information related to a project. It contains all the files that make up a project, as well as all the metadata, tracks, changes to those files over time. Now, the structure of Git repository is divided into two main areas: the workflow directory and the Git directory. Now, what is a workflow directory then? The working directory is the place where you create, edit, and modify your files. So, not inside the dot folder, it's actually outside the dot folder. What you do, that is your working directory, okay, or workflow directory, whatever you want to call it. Now, it is a directory that you are currently working in, and it contains all the files, or folder that you're currently working on. So you can think of working directory as your local copy of the repository that you're currently working on. Okay. Now, what is a Git directory? What's a .git directory? That is the one. So the Git directory .git directory is a place where Git stores all the metadata and the version control information for a particular project. It is located inside the working directory and it is hidden by default. So dot, right? Dot is the beginning. By doing so, is actually hidden from your normal files. It's hidden until unless you run show hidden file ls-a, that means show the hidden files, then only you see the .git directory. Now this Git directory contains all the information necessary to manage a repository, including the commit history, branches, and the tags. Okay. Now, what are the things that contain in this Git directory? Git, object, refs, and hooks. We just saw that, right? So if you come here, say we go to CLI and let's go inside that. I mean, I was just showing you earlier only, right? So this one, head, description, info, refs, all that, right? So let's learn about what exactly are these, this objects or these files. So let's understand that. So this this file point to the current branch that you're working on. Objects. So object is the directory contains all the object that Git uses and store the content of your files, including blob file like file contents and the trees. Okay, that is the directory structures. Now ref, the directory ref contain all the reference to the branches, tags, and other Git objects. Okay, the folder config or the file config, this file contains configuration information for the repository. And then hooks, this directory contains script that Git can run before or after certain actions such as commit, on push, or on pull, whatever the thing events, you can run certain script on as a hook. Okay, now overall the Git repository structure is designed to allow for efficient version control and collaboration on your projects while keeping track of all file changes made to file over time. Very important, right? Now let's learn about the Git Object Model. So what it is? So Git is a distributed version control system that that store the content of a project as a set of snapshot or commits. Now the Git Object Model is the way Git internally represent and store the content and history of a project, right? All this kind of commits and all that. So Git Object Model consists of four types of object. First one is the blob. Now what is a blob? A blob is a binary large object that represents the content of a file. Blobs are used to store file contents in Git. Now the second one is tree. So a tree or a directory like object that represent a snapshot of a project or a particular point in time. A tree can contain other than trees and blobs, okay, and represent the hierarchy of files and directories in the project. Now the third one is commit, okay, and a commit is an object that represent a particular version of a project. A commit contains metadata such as author, such as date, such as commit message, and as well as the reference to the tree that represents the project at that point of time. So anytime you want to go to a particular version of the project, you actually check out, or you go to the particular commit of that time, okay, to go to the particular version. Like at particular commit, what you have done, you can go to the commit and see exact same structure of the files and folder, everything. Okay, that is the commit. Now a tag. So a tag is a lightweight object that points to a particular commit. Now tags are often used to make or mark releases and other important points in a project history. Okay, kind of break points, or say the release history, all the stuff you manage by the tags. Now Git uses a content addressable storage system, which means that each object is identified with a unique SHA-1 hash, okay, of its contents. Now this allows Git to easily verify the integrity of objects and detect any changes. Okay, so in order to detect changes that one file changed somehow, so their signature, this SHA-1 value will change. That's how Git detects, okay, a file is changed, or a directory is changed, whatever it is. Mainly a file is changed. This is how it checked it. Okay. Now the Git object model is a key to understanding how Git tracks the changes in a project and allow user to navigate the history of a project. That's why it's very important to understand the Git object model. Now I hope you understand the Git object model, right? Now let's learn a bit more about this Git working tree. Okay, now the working tree in Git refers to the current version of a repository that a user is working on, and it is the place where developers make the changes to the files of the project and test their code before committing their changes to the repository. Now when a clone or checkout of the Git repository happen, the entire project downloaded into your local machine, creating a local copy of the repository in your system, and the files and the directories in that repository are stored in the .git directory. And when you make changes to any file or the file in your working directory, Git will track those changes and allow you to commit them to repository. Now what this means, this simply means, see, anything out of this .git, okay, so that, now this simply means anything outside this dot directory. So we do ls dash la. See, this outside this dot git directory, out of this git directory on your main project or main directory where you have set up this repository, any folder files that you make changes until unless you mention in a dot git ignore file, that are the working tree. So anything you make changes, that you have to commit and push it to the main repo. Or suppose you are pulling the repo from cloning the repo from the remote location, then all the files are populated from the remote to your local system, right? There also, any file you made changes, then Git will detect the change, and suppose you want to push to the the remote repository. Now what is remote repository and all will come to later slide, but think that somewhere in the internet the code was stored and you pull the code from that place to your local system. Now from the local system again you want to push to the main repo, the remote place where the code is existing, then you have to first make a commit. Of course you have to add the files and then commit it and then push it. Okay, so you do all that in the working directory. That simply means the working tree, these files and folders outside .git folder. Okay, say sample.txt for example, or maybe say I'm writing another file, touch abc dot pdf, anything. Okay, so if you do ls, if you simply run the git status, you see it's saying 200 files. So Git is tracking all this file. It's untracked. If you can add it, and of course in then Git will start tracking it. If you want to push this to the remote repository or remote place, then you need to add the file to tracking, and then you have to commit it and then push it. We'll come to all this, why I'm talking about this adding, why I'm talking about this committing, why I'm talking about the pushing. We'll come to all that. Okay, but think this is the working directory that is outside of the .git folder. That is the important part. Okay, now let's understand about this clone part. Now Git clone is a command that is used in Git to create a copy of the repository. When you clone a repository, you create a copy of the entire project, including all its files, the full version history of your that particular repo into your local machine. And this allows you to work on a project locally, make changes, and then push those changes back to the original repository. For example, we run this git clone, then the repository URL that you have, it will simply create that particular repo folder in your local system, and along with all the files and folders. Let me show you how it works. Okay, now to show the cloning in practical way, let's use a GitHub remote repository and we will clone the repository in our local system. Let me show you how it happens. Okay, now let's go to the URL on the browser, of course. Then let's go to GitHub. Okay, so GitHub, and by now you know GitHub is a cloud repository. I mean, cloud hosted Git. Okay, you can say GitHub is a cloud hosted Git. Okay, now in GitHub, let's create a repo first so that we can clone in our local system. So let's say new, and then the first one will get actually public. Okay, later on I will show you how to get private. Okay, now in the repository name, let's call it repository name demo repo demo remote repo. Okay, that sounds good to me. Demo remote repo. Okay, if you want to give just to show how cloning happens. Okay, that's it. Now public private, I'm getting for now public, but I will show you a private repo also later in the slides. Okay, do you want to add a readme? Now what is readme and why you need to add that, we'll come to that also later on. So let's add it for now. For example, now git ignore, if you have say any programming language, particularly say for example I want to run git ignore for Python. Okay, so you will get a selection. It will already have most of the files that should not be pushed to git. Those you can use git ignore for. Now git ignore also what it is and how it works, we'll come to that later on as well. For now, think about exclude folder, we use git ignore. Okay, for example Python related which should not get pushed, we can use that one. License, is it open source? Then you can give any open source. If it's private, then you don't give any open source license. That's it. Now if it's open source, right, so let's give it a MIT license. Okay, for example, now what is these licenses? It should be your homework to go through all that. Now click on the create repository and it will create the repository. Okay, now to clone this particular repo, what you have to do, first go to this code section. There's two ways, using HTTPS and using SSH or using GitHub CLI. It's up to you what you want to use it. Usual cases, either you use this HTTP or use SSH. Let me show you both way. How can you do with HTTPS and how can you do with SSH? First with HTTPS, let's go there and go to the console CLI. Now here let's clean this up. Let's go to some other folder. Let's call it. So this particular repo is actually named demo repo, isn't it? So while copying say cloning, this will get created automatically. This folder demo remote repo will automatically get created in our local system. Let's do that. I think that will be very good thing to show first. Now let's come here and let's run git clone. Now let's copy this particular repo link for HTTPS, this one. Okay, and see, it's cloning into this particular folder, isn't it? So it's creating the particular folder demo remote repo, because in my system there was no such repo, right? We just newly created. Now if you go to this demo remote repo, it will be not much thing, only one readme file will be there because we allowed it to create while creating this repo, right? And the license also is selected MIT, that is there. Now if we made any changes, I mean it's our private repo, I mean not private, it's public repo, but we are the owner, so we can easily push, we commit, and all this will show later on. But for now, this is how we clone it. Now we can clone this one in using SSH, that's SSH also. Let me show you how you can do that. So let's go to the browser only and let's go to SSH. Now you don't have any public SSH keys in your GitHub account. You can add using add the key. So I don't have a public key. Let's go and create a public key first. Of course, the key system works in a private and public key. So let's create and add in our GitHub account. So let's do it. So first let's actually go to this, just go to the main page. Here you get the option to generate, like how to generate the SSH key. You will get it here. So check out our guide to generate SSH key. Let's click on that. And see this option, generating a new SSH keys and adding to SSH agent. We can use that one. Okay. Other options are there. adding key to your adding a new key to your SSH key and all that is already there, but you have to first generate it. So let's generate it first and then we'll add it. So come here and you can use SSH keygen, then -t, then ed25519, this is the encryption, -t, then your email. You should simply generate that one, and it will generate, of course, a public and private key pair. You just need to check what is the public key, and public key value only you have to post in your, add in your account. Okay, so let's first generate it. So copy this line, SSH keygen and all that, and your email. So let's copy up to this, and email will be our personal email, right? So we'll do that. So let's go to the CLI again, and let's go back and just remove this particular folder, demo remote, then repo. Okay, let's remove this particular folder because we'll be doing in rm is rf demo remote repo. Okay, it's removed. Now let's do generate the file first. So that thing copied from here, in this part we copied that particular command, right? Let's copy this in our CLI. So let's actually clean up first. Actually, it's too much cluttered, so let's clean up. And my email is, say, the dot last 5 the rate of gmail.com. Let's generate it as a generating public private key with et259 care. Enter a file which enter file in which you save the key. You see, it's getting id, then ed2513, enter. And if you want any passphrase, you can enter. No passphrase, same. I'm not giving any passphrase, right? Educate the key. Now this is the public key. So to check that one, say cat. Okay, I have this public key, so I can simply copy this one, and then I will go to the browser, and I will go to my this screen. This screen actually pretty basic. You go to this one, and then you click on this your settings, and there is an option called SSH and GPG keys. So click on that, and then you see the SSH keys. Click on new SSH key, title my laptop or whatever you want to call it. Okay, you just mention here authentication key, signing key, authentication key, and paste it. Okay, and add the SSH key. And of course I have the 2FA enabled, so I will go and have the 2FA verifying, and of course it's added now. So yes, this is how you add your public key. So now while cloning, you use the SSH option, and this is the copy. So copy this, and now come to the system and open this, clear the screen, and run this git git, go just a bit more back, like git clone, then this SSH cloning path. That's it. It's cloning the repo into my local system. That's how easily you can add your GitHub keys, and you can clone the repo. So this is how we do clone by the HTTPS or SSH. Okay, this is how we do it. Now that you have understood what exactly GitHub repo, how to create repo both locally and remotely, for example in GitHub, and how to clone a GitHub repo from remote to our local system. Now let's learn a bit more GitHub concept. So the next one is actually my personal favorite, is the branching. Okay, so what exactly is branching? So let's come to that first, right? Now a branch, a Git branch is a Git command used to list, create, or delete branches in Git repository. Now in Git, branches are pointers to specific commit in the repository's history. Each branch represents a line of development, allowing developers to work on multiple feature or bug fixes simultaneously and independently. Now by default, when you create a Git repository, it the branch, by default branch call the master or main branch, depending on which version of Git you're using and which repository you're using. Either master or main should be the default repository branch. Now which points to the latest in the repository's history. However, you can create multiple branches using the git branch command to work on different features or experiment with new ideas without affecting your production code or the main branch codes now in the main database, right? So that is a entire point of using branch. So you work on different ideas on different branch. Once you want to release that particular branch or all that sort of changes to production or in the main code repo, then only you use that main branch or main repo. Okay, other thing you work on other branches, right? And this, there are concept merging, pulling and all that. We'll come to that a bit later on. But think that Git branches are one of the key points or the important part of working in Git. Okay, you understand now what is branch? Um, it's simply creating a kind of a new section where you make your changes, and if you want to merge the new section with the main section, you merge it, or you pull the main branch changes into the new section. You can do that. You can do all the stuff. Okay, now when run with no argument, Git branch will display a list of all the local branches in the repository, indicating which branch is currently checked out with an asterisk. Okay. Now, some of the most common example of Git branches are like, if you run Git branch, it will list all the local file, also local branches. Then if you run Git branch, new branch, it will create the new branch. Git branch -t, then the branch will delete, it will delete the branch that you created. Then Git branch -m, old branch, then space new branch, it will rename the old branch to new name. Okay. Then Git branch -a list all the local and remote repositories, or sorry, local and remote branches. And then Git branch -v list all the local branches along with the commit message and hash of their most recent commit. Okay, these are the most common use cases of this Git branch command. And commonly used Git branches, like what are the name or what are the kind of Git branches getting used? That is master branch or main branch. This is the primary branch of the repository which represent the main line of code base. Then you have the feature branch. Now, a branch created to independent new feature or work on a specific task. This is the feature branch. It is typically created of the master branch, like the main branch it's created, and once the feature is complete, again it merges back to the main branch. So suppose you created a you are working on a feature, say feature 1. It's actually created from the master branch. You done with all the changes, whatever you do achieve all the business logic. Once you're done, you merge, or you like all the changes of the new branch, you push into the master branch or the main branch, okay, or the main code base branch, right? Then you have the hotfix branch. Now, what is this hotfix branch? A branch created to fix critical issue. That is, we have this, or say production. Most cases in production, there's some problem, you want to fix it quickly. For that, we create the hotfix branch. Now, it is created on the release branch or the production branch. Once the fix is complete, just push it back to the main branch. It is merged back into both the master and release branches. So of course, if you are fixing it, if you are maintaining separate release branches, of course you are pushing to release branches, and at the same time, of course, you have to merge to the main branch as well, because you want to make sure both places the bug is gone. Okay. Now, if you don't have a separate release branch, you probably should push only the main branch or the primary branch. Okay. And then development branch. So a branch used for ongoing development work, separate from the master branch, and it is of course separate. It's a separate branch. Development, you normally whatever development work you do, this ongoing development, you put in this development branch. Okay. Then changes made on this branch are merged into the master branch once they are stable and tested. So once you're done with your development and change and all that, you merge all the changes into this master branch or main branch. Okay, this is the branching policies. The branching commonly used branches are, as explained now. Now, let me show you in a practical way how to work with branches. I think that's what you're most interested in, right? So let me show you quickly how to work with the branches locally. Okay, so I just created, I mean, we clone this repo, isn't it? Or we can just create a new repo also. So let's see, let's actually clean it up. So we have the cd demo remote repo, right? So let's go inside that. You can create a branch here also, like it's a remote clone, right? So, and there mainly you see ls, that's la, it has this .git folder, right? That means it's the Git repo, or where you can add changes and you can see the change and all that. So now to create a, this is if you run git branch, it lists, okay, it's some only main branch. Okay, now suppose I want to create a new branch. For that I will run checkout git checkout dash b, then you give the new branch name, for example sample new branch. Okay, then you do run the git branch. You see, now we have created a new branch, and asterisk sign, this asterisk sign shows that I have created and checked out to this new branch. Now if I want to move back to the main branch, what you should do, let me show you how to change back to the main branch. Git checkout, then the branch is main, right? So main, and now if we do, you saying that switch back to the switch to branch main, and now you are up to date with the origin main. Now if we run git branch, okay, see, we are now asterisk in the main, so we are now in the main branch, not in the sample new branch. Now if you made any changes in the new branch, for example, let's again check to the go to the new branch, git checkout sample new branch. Okay, see here, so it's right now there is no much changes. We see git status, nothing, right? Now let's clean this up and let's create a new file, touch sample dot test txt, whatever file you want to call it, you just add it, then do run git status. Okay, it shows this change happened here. Now this change, suppose you add and you are just, let's say for example I am adding these changes, you will come to know how what is adding and what is committing. I'll just quickly show adding and committing. Okay, git add, then this particular file, so I'm adding that to my state changes, then I'm committing, I'm saving that particular change in this particular branch. So git commit, then dash m, then new code. Okay, new changes. Okay, now let's run it. Okay, now git status, see, and if you do ls, it's saying that I have three files, license, readme, and simple test file. Now what if I check to the main branch? So git checkout main, see, now if you do ls, see, I only have two files because that change, that file I have created in the another branch, right? That's why that's in that branch. Now we check back to the main branch, we don't have that. Till we merge or do we pull the changes from another branch to main, we will not have the latest changes of that particular branch. Okay, so that's the complete separate branch, separate path, separate section, main is separate section. That's how you should remember it. Okay, now I hope now you understand the branching part. Now suppose I want to delete the branch, what we'll do, so git let's first list the branches. So this sample new branch, let's remove this, git branch dash d, then the branch name. Okay, it's saying error is not fully merged, so if you are sure that delete it, run d dash, and you have to do the say capital D. So instead of small d, let's do run the capital D, and it will remove the branch. Okay, like a force delete kind of stuff. Okay, now if you run the git branch, see, it's saying only the main branch. So this is how you use branching strategies. Of course you will see more of this kind of stuff as we move towards the next slides and next learning next concepts. Okay, now let's go back to the slides again. So now you understand the git branches, right? We get separate section in our repository. Okay, based on our need, maybe for feature, maybe for bug fixes, maybe for whatever the reason, we create a separate branch, we make our changes so that our main repository codes will not get affected. That's the main goal of this branching strategy. Okay, now let's learn about the checkout. I think I show you checkout, right? Checkout dash b part is created a new branch. So git checkout is the command for the git version control system that is used to switch between different branches and create a branch and check out a specific commit or a file. Okay, now switching branches, I mean there are the most common cases checkout. We'll just go through that first. Switching branches, to switch an existing branch we use git checkout, then the branch name I already show you, right? Now this will move your working directory, so current working directory is moved to that particular branch, that particular folder, list of files and folder, all the contents there. Now to we can use git checkout to create a new branch. I think I already show you git checkout git checkout as b command. So to create a branch and switch to it, you use git checkout dash b command and then the new branch name. This will create a new branch of the current branch. So wherever you're working on, suppose you're master, if you run this command git checkout b, then it will create a new branch and base branch will be the master. Suppose you have XYZ branch, okay, from there you create another branch. So from you have to first check out to say for XYZ branch, and then you check out git checkout dash b, then the new branch name ABC. That ABC branch will create from the XYZ branch. This is how this checkout new branch checkout works. Okay. Now checking out a specific commit. If you want to see that in a particular commit, what was the files and what are the folders that particular commit state, you can do that. So to do that, you have to run that git checkout and then the commit hash. The moment you keep check out the commit hash, your repo's working directory means outside of the .git folder, all the contents will move to the particular git commit. Okay, you can see in that particular git commit what are the files, folder and everything. Okay, now check out a particular file. Now to check out a specific file from a branch or commit, we use git checkout, then branch name, this commit has, then the file path. Okay, and this will replace the contents of the file in your current working directory with the content of the particular specified branch to or the commit ID that you are selecting. Now this is very important to note that git checkout can modify state of your working directory and potentially override the changes that you have made. There is a risk involved. You have to be very cautious when you use this kind of commands. Therefore, it is very important to use it with caution and make sure you understand what you're doing. That's why it's important to know all this stuff. Okay. Now let's move to the next point. Now let's understand about the stage area. Okay, or staging area. So in Git, the staging area, also known as the index or cache, is a concept that refers to the intermediate step between modifying files and committing those changes to the Git repository. Okay. Now when you make changes to a file in your Git repository, those changes are initially only tracked in the local working directory. In order to commit those changes to the Git repository, you need to first add them to staging area. Okay, so you run this Git add command. We'll come to that only. Okay, later on. Now this staging area essentially is a snapshot of your current directory at a particular point in time. Now you can use Git add command to add modified files to the staging area. Once a file in this stage, once a file is in the staging area, you can review the changes and make any necessary modification before actually committing the file to the repository using the git commit command. Okay. Now using staging area can be helpful in a number of ways. For example, it allows you to review and selectively add changes before committing them, which can prevent mistake and ensure that you only commit the changes that you're ready to add and share with other people. Okay. Additionally, using staging area can help you organize and structure your commit more efficiently, which can make it easier to track changes over time and collaborate with others. So simply means what this means that when you make changes to in your working directory or in a Git directory, I mean in the same the Git working directory, which is outside of the Git folder, that is your current working directory where there your main codes, your main files are, right? So those things are there, and the moment you keep changing and changing and you add, like you run git add that particular file, that means that file now added to the staging area that is getting tracked. Okay. Now suppose you want to make 10 times changes to the file, please do it, no problem. But after, like say you keep changing, that will get updated and you will say it's modified and modified. Then once you're ready, you run the git commit command, then the changes will be committed or saved to the particular local repository. Now if you want to push to the remote, you run the push command. We'll come to all that. Okay. Now just the conceptual to make you clear, staging area only means that you add a file to be tracked or staged. Okay, so GitHub will track actively and it is ready to be committed, that state. Okay. Now let me, while you're talking about the git add, why not we actually add a file and let's see what is the staging looks like. So let's first understand about the git add command. So in Git, the git add command used to add changes to the staging area. So we used the git add command to add files and other any files to the staging area, like waiting to be committed. Okay, which is an intermediate step in the process of committing changes to the GitHub, like the step before committing. This is the staging area. where you make changes to a file in your working directory. Git initially tracks those changes but does not automatically add them to staging area. So even if you keep making changes, Git will tell you, wait, you made a change. There is an untracked file. But if you track the particular file, you have to add them to the staging area, which is using Git add, then the file name or path. That way, Git will add them to the tracking, and it will keep tracking the file or folder, whatever the content it is. Now, to add changes to the staging area, of course, you use the Git add command followed by the name of the files or path that you want to add. For example, Git add and the file name. This command add the changes made to the particular my text file, for example, here to the staging area where they can be reviewed and modified before being committed to the GitHub repository using the Git commit command. Now you can use the Git add command with the wildcard pattern. Suppose you want to add all the txt file, then you can give the pattern matching. So Git add start.txt. Suppose you want to, like, whatever the file folders they are made changes, you want to like all add everything to the Git tracking or Git staging. Then you run Git add then dash all or dot or maybe simple a, then it will add all the files or like everything that you have changed to the Git staging area. Now let me show you. I think that will make things more clear. Okay. Okay, so now let's clear this. We are in the demo repo. Now why not just create a new repo and let me show you that, that will be more easier. So let's create a mkdir. We'll call this say repo demo, Git repo demo. Okay, repo demo. Now let's go inside this Git repo demo. Git okay, I think I should first rename this. So we call it mv git. It should be demo. I make it demo. So demo underscore repo. Okay. Now go inside this Git demo repo. Now let's, like, it's now a simple folder. It is not a Git repo. In order to make it a Git repo, we have to run Git Init, right? You remember now? We run Git Init to make it a repo. Now to, like, right now if we do Git status, there is no changes. Okay. Now the moment I am say I'm creating a new file. Okay. So touch abc.txt, touch say sample.pdf. So whatever the files on code, say touch your normal code, for example, touch sample module dot php python, okay, dot py. So now if we do git status, see Git saying Git not tracking actively. Git just saying, see, we have untracked file. If you want to add these files to the Git tracking for staging, then you have to run this Git add command. So let me show you the Git add, then this particular file, and now if you run Git status, see it's saying, wait, look at it, new file added. Git is actively tracking this particular file abc.txt. Now suppose I made any changes to this file, so this do change nano abc.txt and say some random body, go and save. Now let's save it and again do git status. Git will say, look, you modified the particular file, but it will not show the same modified for this too, because Git is not actively tracking those. Git only tracking the thing that you've added, this abc.txt. Okay, and that is stage. See, changes not stage for the commit. The main, that file, blank file, it actually stage for commit, but the new thing or new changes that you have modified, that is yet not stage for commit. See, saying changes not stage for commit, like changes are not ready to commit. You first like if you want to do that, git add then abc txt, then git status. See, now it's saying new files, now it's stage, right? So this is how Git track all that. Okay, now if you want to add everything that you have, the sample pdf, sample module.py, we run git add then like dash a. Okay, and if you git status, it's all file now stage to commit, right? This is how we add all the files to this particular like all the file, we add all the files in the staged. Okay, which is just the step before getting committed. Okay, now since we're talking about commit so much, why not we discuss about what exactly is a commit, right? So Now let's learn about the commit. So what is commit? Commit, a Git commit is a command used in the Git version control management system to save the changes to a local repository. Now, when you make changes to the file within a Git repository, you can stage the changes like we now stage multiple files, right? Using Git Add command. Now, which add the changes to the staging area. Once you have staged all the changes that you want to include in the commit, okay, you can use Git commit command to create a new commit. So the moment you're committing, that means is actually saved. Now, no matter you move to any particular branch, again come back to this branch, you will get exact same file waiting for you. Okay, that is the meaning of this commit. Now, this Git commit allow you to provide a commit message. So while adding or committing a particular file or contents, you have to particularly specify why you are adding the particular file in a meaningful manner. Now, which should briefly describe the changes that you are committing, and it is important to write clear and descriptive commit message, and as they help other people to understand, or maybe suppose you are creating codes, you are writing codes, you are adding codes, then you're going to commit and you're committing code changes. Now there is a senior engineer coming to review your code. If you don't use proper reviewing, that senior engineer will definitely tell you, because you will not understand why the hell you made these changes. So you have to give the reasoning, you have to give the messages in the commit, so that senior engineer while reviewing the code, or maybe for any audit going on, they see this is the reason you made the code changes. Okay, that's why while doing the Git commit, it is important to add a meaningful message. Now here is a quick example of the message. So Git commit -m. M means the message. Then this added new feature for this web app. So for our case, let's go to the CLI, and we have this file ready for to be staged. We use this git add command, git add -a command to like all. You can use git add and the particular file, for example sample pdf, to add particular file. For example, let's say I'm adding a new file. Let's create a new file, touch, let's say touch, then abc.js. For example, it's if you go to git status, you see all like previously we added this file is edited, it's in the stage mode. Now this file actually not getting tracked. Now suppose we add git add, then this particular file, it will be add to the stage. Okay, just the stage before getting committed. Git status, so it's ready to be then the git status command, it show that okay is actually ready to be changes to be committed, like changes can be committed. Now the moment I run this git commit, then -m, and then say all new code changes, for example, it would be any message that based on your use case. For example, here I'm just giving demo message, and see all these changes are now committed, now saved to the particular branch. Okay, and if you go to any other branch, you come back to this branch, you will get exact file and folders waiting for you in the working directory. Okay, so this is what a commit look like. And of course, when you make a commit, it will give you a SHA, which is the this part, which is saying SHA-1, so that suppose you make any changes, you go to any other branch, you do any changes, suppose you want to go back to the exact this state where you have these files and everything is saved, you can come saying say the git checkout, then this particular SHA. Okay, now you understand what is adding, what is the staging area, and what is committing, which is actually saving the changes to the particular branch. Okay, and now you understand this. Let's understand the next concept. Let's learn about the next concept, which is the git push. So that you clone the repo, you made some changes, you committed the changes. What is the next step? The next step is actually to push all the changes to the remote repository. Now if you remember at the beginning while showing you the git cloning, I actually created a GitHub repo, and like I cloned my local, right? So why not we go there, make some changes, and push our changes to the remote repository. Now before doing that, let's understand the push in more thorough way. Okay, so git push is a command used in the Git version control system to upload the local repository changes to the remote repository. This command is used after making the changes to your files in your local repositories and committing those changes using the git commit command. the basic syntax for git push command is as follows. You can see git push, then the remote, then the branch. Okay, now here remote refers to the name of the remote repository that you want to push your changes to, and the branch refers to the name of the branch that you want to push your remote repository. So the branch, of course, the branch you pulled or make changes in your local repository, you want to push the same branch to the remote repository. Okay, now for example, the push changes to the local master branch to the origin remote repository, you should use the following command: git push origin. So when cloning from the the repo, the origin means the main URL. Okay, the initial URL that you have used to clone, or maybe you later on adding as a remote repo. We'll come to that remote commands and all. So what initially, just think about adding a remote repository at the beginning. You have this origin. Okay, so git push origin means the original URL of the particular repository. There, then the branch. The branch is the master. So this command will upload all the changes that you have made in your local master branch to the master branch in the origin remote repository. Now it is important to note that you might encounter errors while pushing changes if there is any conflict between the changes made in your local repository and the changes made in the remote. Suppose someone like made the same file change in the remote repository, somehow there is a conflict. Okay, and in those cases you will get errors. So you have to pull the changes first, like maybe before you push any changes, some other people pushed it. So you have to then run git pull command first before making any push. You have to remember that part as well. Now let me show you in practical way how to push the changes to any remote repository. Okay, let's go to our CLI. Now first, let's actually in our browser, let's go to the repo we have created. I think you guys know this repo I have created. Now this repo, this is the demo remote repo, right? And we clone this repo in our local repository. So let's go to the particular part. Let's simply go back, then cd, then demo remote repo. Now if you want to check what is the remote the repo URL, we can run git remote -v, and you can see origin, the repo we actually we cloned, we call origin, and then git what is the URL. So origin, then this is the origin particular remote path. Now if we want to push our changes, let's first make the changes. Of course, we don't have any changes here, right? So if you do git status, you will see we don't have anything to push. Let's add some files, touch abc.py. So any code change that you made normally, say touch xyz dot xyz.py, right? And this is how we can add files. Now if you do git status, you see we have this abc.py xyz.py, right? So let's do git status, and let's first add particular two files to stage. So git add, then git py, and giving a space and say another file name. You can add multiple file like this also. So if we do git status, you will see changes are now ready to be stage, ready to be committed. It's stage mode, right? It's stage. Now Git is actually tracking these two files. Now we want to commit this file to local repository first. So locally it will be saved to the particular branch. So git commit, then m, then say our code changes, our latest code changes. Okay, now so it's now the code is actually changing the save to our local repository. Now I want to, like, if you like, is it to local only. If you do reload this or say refresh this particular repo page, for example, it's not there. If you even keep refreshing and refreshing, still it's not there. Value is not there. If you want to push our local changes to this particular repo, we have to run this push command. So let's go to the CLI first, and then use git push. Now come here in the status, we have checked what is the origin, right? Now origin is the main remote repo for push, right? So git push origin, then which branch you're working on? Main branch, right? So main. You have to wait for a few seconds, and see it's saying the changes are pushed now. Now if we go back to the our repository there and we reload our repository, you see the files are now available here, right? This is how we push our changes to the remote repository. Now that we have learned how to push our local changes to the remote repository, now let's think other engineers are there. Maybe you didn't had your local system like this, and somehow you got another system. You just maybe directly go to browser and made some changes. Could be any reason. Either other engineers made some change in the remote repository, or you made outside of your local system. Okay, and now in your local system or say local computer, you want to pull all the changes, latest changes happen in this particular branch. How you can get all the changes? For those time you have to pull command. So what is the git pull command? So git pull is a git command that used to fetch and merge changes from the remote repository into a local repository. And when you run this git pull command, it performs two operations. First one is git fetch. So this command actually download the latest changes from the remote repository and store them in the local branch name origin then slash branch name, where the branch name is the name of the remote branch that you're working or you're tracking. Then git merge command. So this command merges the changes downloaded from the remote repository into your current branch. Okay, and if there are any conflicts between your local changes and the remote changes, you have to you'll get prompt to resolve those by yourself, and then after you've done the resolving, you can continue the merging. Now here is an example how to use git pull to update your local repository with the changes from the remote repository. First navigate to main local repository, and then run the git fetch command, and then run the git merge command. Now you don't have to run these two command, to be honest. You can simply run the git pull command. So now let me show you how you can do it. So next example is our remote repo, right? And you can actually directly from the repo add file, right? So create a new file. Okay, so let's make some changes. Like say dummy file, let's call the file name as dummy file. Okay, and put any dummy content that you want to push. Okay, just any content. Now go down and see it's asking to commit to the main branch. So let's create, or let's get dummy file, and it's creating the file. So we have the new dummy file. Now since we have made changes, added that file manually in the remote repo, right? And we want to make sure our local repository also we have those changes available, right? So we can run this particular command, just like explain git pull, and it will simply pull that particular change into our local system. Okay, see, let's see that ls. See, we now have the dummy file, that particular file available in our local system as well. So it's simply what it did. It behind the scene it run the git fetch command, and it run the git merge command. Okay. Okay, now you learn about how to pull the changes from the remote repository into a local system as well. Okay, now we learn how to commit, how to add to stage, how to commit, how to push. Now let's learn about the stash. Okay, so what is a stash? Git stash is a command in Git that allows you to temporarily save the changes you have been you made to working directory and revert it back to the last commit. Now this is useful when you need to switch to different branch on work or to a different task, but don't want to commit the changes that you have made so far in the particular branch. Could be for any reason, you just don't want the changes you made to commit to a particular branch. That could be a very good use case, right? Now when you run git stash takes Git takes all the files that is changed in your working directory that are not yet committed and store them in a stash. Okay, and store them in a stash. Now you can switch to different branch or task and continue working on. Now when you are ready to get back to the changes that you have in a stash, you can run this git stash apply to apply the stash back to your working directory, like the thing that you have removed and move back to the last commit. Now you can revert, you can get back all those files, okay, into your working directory. And here are the common git stash commands that I've just mentioned. You can see here that git command stashes all the changes you have made to the working directory. Git stash save, then the stash message. This command allow you to provide a message describing the changes that you have stashed. Then git stash list will command will show the list of the stashes that you have created. Then you have this git stash apply. This command applies the most recent stash to your working directory. Then you have this git stash apply, then the stash at the rate of, then in third brackets, then 2. This command applies specific stash to your working directory. Then git stash drop, the command delete like most recent stash. It will simply remove all the files in the stash. Git stash pop, this command applies the most recent stash and then deleted it. Okay, now these are the very important command, and let me quickly show this git stash command. Okay, let's go to the CLI, and for example, say I right now if you do git status, see no file is actually in the working directory to be committed or staged. Right now let's do git let's do touch, like we are creating a new file and say sample file test dot say py. Okay, that means we have a sample Python file. For example, if you run the git status command, you will see the file that we have created in the this here. Right now, suppose we want to stash it, we have to first commit this one. So let's say commit. Now if you want to stash it, we have to just add. Suppose now we have added the particular file, so git add this particular file name. Okay, and now you don't want to commit this one, what to do? So for that you run git stash. Okay, and see saved working directory and index working with main. So we move to the last you can say last commit. Okay, so if you run git status, it will simply so okay, we have no files, so that particular file move to the git stash. So if we now run this particular say git stash list, you will see now upon running git stash list, you will see there is a stash save for this particular, like you are in that particular work in progress branch where you made the stash, that is now available. If you want to clear it, so you run git stash then drop. Okay, and that will remove that particular stash. If you do git git stash list, you will see that's that stash is not available anymore. See, that's gone, right? No such stash. This is how you working sometime, you don't, maybe you meet some mistake, you don't want to commit that particular files and all, you can stash this and you can remove it like this. Okay, now that you have learned what is git stash and how it can be helpful, let's jump to the next key git concept, that is tags. Now what are the tags? So git tags are the markers that are used to create a name refers to specific commit in a git repository. Now this can be used as a label specific to specific points in the repository's history, such as release version or important milestone. Now there are two types of git tags, lightweight tags and the annotated tags. Okay, a lightweight tag is simply a pointer to a specific commit. It created by running the following command. You can see the command here, git tag and the tag name and then the particular commit ID. Okay, an annotated tag is on the other hand is a full object in Git which includes a tagger name, email, date along with a message as well. It is created by running the following command. You can see the command here, git tag then -a then tag name, commit and -m in the message and the following message you have to provide. Now annotated tag can be often used as a mark for the release versions, while lightweight tags can be used for say purposes like once a tag is for maybe other purposes. Okay, now once a tag is created, it can be pushed to a remote repository as well using the following command, like git push origin then the tag name, and then to list to list of all the tags in a repository, you can run the following command, git tags git tag, and you can also view information about specific tag by running the following command, that is git show then the tag name. Okay, overall git tags are a very useful feature for organizing and in marking important point in the repository's history. Okay, now let me show you how it gets done, and that's how you will get practice, right? So let's do it. Now let's clear the screen first. Now to create a tag, you have to just say git then tag and then the then tag name, say sample tag, and for the commit ID you can of course list out from your current repo. Another very easy way, since you are just learning up and all, you can go to the remote repositories. For example, just go to the remote repository and see the last commit. You just refresh the page and you can see the last commit ID. This one is the last commit ID, right? So let's copy that one and come back to the CLI and there give the tag ID like this, and see we have created the tag. Now suppose we want to say push this particular tag to the repository. What do you have to do? We have to run say git then push origin then the tag name. So tag name was what? This sample tag, right? So copy sample tag and push it. It will push this particular tag to the remote repository. For our case, which is the this particular GitHub repo, right? So now let's go back to the remote repository. Let's go there. Let's go and check what it looks like. So let's refresh the page. You can see the tag section. Now we have one tag. So let's go to tag and see simple tag, right? So you can download the zip, you can download tar, right? So this is how you can create a tag, which is most of the cases it's marked up a release history kind of stuff. Okay, now you already understand about this, how to create a tag, how to push the tag to the remote repository, right? Now why not actually see more info? Suppose you want to see more info about a particular tag. So git so that for that you run git then show then this particular tag name. Okay, if you do that, it will show the exact things that you have just pushed for this tag. Okay, this is how easy it is to use tags. I hope now you have a very solid understanding of what is git and how to work with git. The basic is now a lot clear, isn't it? Now thank you for joining me on this git course part 1 journey, and I hope you find it informative and very helpful in your understanding and basic use of git. Now git is an essential tool for developers and anyone working with codes. Now I encourage you to continue practicing and experimenting with just the thing I've shown you. Why not practice it, right? And remember that the best way to become proficient in git is through hands-on experience and real trial and error, because trial and error teach you the real life stuff. Now if you enjoyed this course and want to see the part 2, please consider subscribing to my channel. And by subscribing, you will stay up to date with the latest my videos and other courses as well. And you will be helping to support the creation of more educational content just like this. Thank you again for your time and attention. And I look forward to see you in the next future video, like part 2. I hope to see you there, right? Bye. And don't forget to subscribe my channel.